Hi, pre-algebra students. So tonight we're going to take a look at notes for section 1.3 on solving equations with variables on both sides. So far we've solved one and two-step equations, and we've worked on multi-step equations in 1.2, but today the new step is this idea of collecting variables on one side of the equation. So for example, if you look at equation 1, you have a variable term on the left side of the equation and a variable term on the right. Now, we've talked a lot about collecting like terms, but remember, like terms can only be combined when they're on the same side of the equal sign. And as you can see, they are not on the same side of the equal sign here. So we want to work to get the variables on one side and the constants on another. So because the constant is already on the left-hand side, we're going to try to get the 2x to the other side. And the way that we do that is by using an inverse operation. So I'm going to add 2x to the left, 2x to the right. Remember, this is our zero pair, so it's going to cancel. Our 15 is going to drop down. And using our integer rule, negative 7 plus 2 is negative 5x. Now we're down to a simple one-step equation. So we're going to divide both sides by negative 5. 15 divided by negative 5 is negative 3. Over here, our 5's cancel, so negative 3 is equal to x. That's our solution. Okay, if you notice, it asks us to check. So remember, for the check step, you take the solution that you found, you plug it in place of x on the left and in place of x on the right. So it'll say 15 minus 2 times negative 3 is equal to negative 7 times negative 3. We're going to solve using order of operations. So here a negative times a negative is a positive. So it's 15 plus 6. And over here, a negative times a negative is a positive 21. And then 15 plus 6 is 21. So 21 equals 21, and it checks. So that proves that our solution was correct. Okay, if you need to, please take some time to stop and look over this example before moving on. In our second example, we're going to add the distributive property to this equation. So now you're going to have to do a little distributing first before you start solving. So notice on the left-hand side, oops, to change that, we're going to distribute negative 2. So negative 2 times x is negative 2x. And then remember, when there's a subtraction sign in front of a number, it makes it negative. So we're multiplying negative 2 times negative 5, which is a positive 10. On the right-hand side, we're distributing 6 to both sides of the equation. 6 times 2 is 12. And then here we're multiplying 6 times 1/2, or actually negative 1/2 x. Half of 6 is 3, so it's negative 3x. Okay, now we're back to that equation with variables on both sides. So we have a variable term on the left and a variable term on the right. Using an inverse operation, I'm going to choose to add 3x to both sides. Okay, there was a little bit of strategy involved there because I'm noticing that 3 is bigger than 2. So if I add, I'll get a positive x over here, which is always nice to work with positives. And then once you simplify and bring down your leftovers, you're down to a simple one-step equation. So you just subtract 10 from both sides. And solving for x, my final answer is x equals 2. Sorry, I hope you can read that. Okay, at this point, I'm going to say follow your teacher's directives on the on your owns. So if you need to, you can pause the video and complete the on your owns. I'm going to go ahead and keep on moving. So this second section is on solving equations that do not have one solution, but either have no solution, sorry about that, or infinitely many solutions. So let's take a look at the vocabulary here. If an equation has no solution, that means it's going to produce a statement that is not true for any value, such as 0 equals 2. And generally, I will write that like this with a slash through the equal sign, just to show you that this says not equal to. 0 does not equal true. That is a false statement. Therefore, it's a no solution. Okay? If an equation has, infinitely many solutions, this, we need to clean up the vocabulary here. This should say it produces an equation that is true for any value of the variable. Let's clean this up. We're going to get rid of the word not, because it should say true, and it wouldn't say something like this. It would say something like 2 equals 2, meaning it's a true statement and it's exactly the same on both sides. So please make sure you make those changes in your note packet. Okay, and let's take a look at a couple of examples that you have right here. So in example 3, we're going to look at an equation that has no solution. Okay? So the first thing we want to do is simplify this by collecting our variables on one side. So I'm adding 4x to the left and 4x to the right. Notice that on each side of the equation, they both create a 0 pair, so our variable term drops out. And we're left with 3 equals -7. Like I said earlier, that is a false statement because that is not true. Therefore, this one is a no solution, which you can abbreviate NS. On the right-hand side, this time we're going to look at an equation that produces infinitely many solutions. We can't do anything to simplify the left-hand side of our equation, but we can distribute the number 4 on the right-hand side of the equation. So I'm going to do a little scratch work on the side. When I multiply 4 times 3 halves, I can cross cancel here. 2 goes into 4 2 times, and then 2 times 3 is 6. So leaving the left-hand side as it was, 4 times 3 halves x is equal to 6x, and then 4 is 4. Okay, so I'm going to go to my next step, which is to combine my variables, or get my variables on one side. So because 6x is positive, I'm subtracting it from both sides. This time you'll notice again the variable term drops out. What you're left with is 4 equals 4, which this time produces the true statement. So we call this one an infinitely many solutions. We can abbreviate IMS. And that means no matter what the value of x is, when you plug it in, it's always going to create a statement. When you look at this second line of work up here, as soon as you can identify that both sides of your equation are exactly the same, that's called an identity. So anytime you see an identity where both sides of the equation are exactly the same, that proves that it is an infinitely many solutions. Okay, I'm going to stop there, and you can try the on your owns if that's what your teacher directed you to do, and be ready for class tomorrow with any questions that you have. Have a good night.